Math 1314, Spring 2022, Tyler Junior College, Section 4.6, Radical Equations, Video 2, Solving Square Root Equations, Type 2. Now, I didn't tell you what made Type 1 Type 1, but when we identify the difference between the next problem and the ones we did before, we'll start clarifying what I mean by Type 1, Type 2, and eventually there will be a Type 3. But first, let's remind ourselves of the steps that we developed to solve square root equations at the end of the previous video. How to solve square root equations. Number one, if necessary, isolate the square root. That's necessary if there live numbers outside the square root. Number two, square both sides and cancel the square. That was supposed to say cancel the square root. So in the previous video, somebody's probably yelling at the screen. It was a horrible place to make a mistake at the end of the last video. Square both sides and cancel the square root. Number three, if necessary, finish solving the equation. And number four, check your solutions. Some of them may be extraneous. So we're going to do the exact same four moves. So what makes a type 2 problem different than a type 1 problem? Well, you tell me. Example, solve the equation, check your solution. The square root of 2x plus 3 followed by outside of the square root plus 6 equals x. So, do you know why I'm calling this type 2? And what makes the other one type 1? If you said there's an x over here, you nailed it. This classification of equations is kind of my own wording. I'm sure there are other ways to describe it. But when I said type 1, what I meant was the variable was under the square root, was only under the square root. By type 2, I mean that the variable is both inside the square root, and let's go change this to inside instead of under for contrast. So the variable is only inside the square root in type 1. And I guess if we're going to use indefinite articles, we should be consistent. Type 2, the variable is both inside the square root and outside the square root, such as in this one. So this is what I'm referring to as type 1 and type 2. Again, it's not industry standard, it's just what I'm calling them. Now, does this change anything? Well, yes and no. No, in the sense that we're going to do the exact same moves that we did before. We're going to isolate the square root, square both sides, finish solving, and then check for extraneous solutions. So no, it doesn't change in that sense. But yes, in the sense that the extra variable on the outside of the square root is going to create issues that we have to deal with as we move forward. Now, these are issues that we dealt with before, so it's nothing new, but it's just more than when there's only one variable inside the square root. All right, so let's see how this will play out. We're just going to follow the steps that we already laid out. The first of which is to isolate the square root, meaning any numbers outside the square root need to be dealt with first. Clearly, that is going to be the plus 6, and we'll subtract 6 from both sides, or at least attempt to. When we subtract 6 from both sides, on the left, we have the square root of 2x plus 3, because the 6's cancel. And on the right, we have x minus 6, which is a problem we can't complete. They're not like terms, so all I can do is write x minus 6. So same first move as before, isolate the square root. And what happens next? Well, once you've isolated the square root, your next move is to square both sides. So parentheses around the left with the square, and then parentheses around the right with the square. And the purpose of that move is to cancel the square root. That leaves 2x plus 3 on the left of the equal sign. And on the right side, open parentheses, x minus 6, close parentheses, squared. But how are we going to solve this? And think about it as I move it to the next page. And 1 second, folks. All right, the work may have jumped around a little bit, but I had some blank pages in between slides, and I didn't want this work to be 4 pages away from the page before, because when it makes the PDF, it would be disconnected. So I had to fix all that. All right, so anyway, as I was saying, we're at the point where we have 2x plus 3 equals x minus 6. And I was asking, how do you think we're going to solve this? Now think about that as I recopy it on this next page. 2x plus 3 equals open parentheses x minus 6 close parentheses squared. Well, stay goal oriented. Our goal is to get the x by itself, and the one on the right is trapped inside the parentheses. So we're going to get rid of the parentheses. But how do you get rid of a parentheses with a square on it? I'll tell you what not to do. Do not distribute the square. There is no such distributive property. Why? Because the distributive property is when you're multiplying outside parentheses, not exponentiating outside of parentheses. The correct way to get rid of that square root, to get rid of that square, and more specifically to get rid of the parentheses, is to write it twice. And you create a FOIL problem. Now, FOIL will work here. First, outside, inside, and last. That's not right. Let's try that again. First, outside, inside, and last. And that will work. But for reasons which will become a lot more useful in the next video, there is a shortcut for multiplying a binomial times itself. In other words, squaring a binomial. If you do the FOIL process, you know the first term gets squared, and you know the last term gets squared. I don't need to write out both parentheses to see that this is going to start with an x squared and end with a plus 36, because negative times negative is positive. Where you need to focus is on the outside and the inside, which we'll do in a different color. But because I'm multiplying the same binomial times itself, the outside and the inside will always equal. So all I have to do is figure it out once and double it. But the truth is I could figure it out at the top, because those two pieces get multiplied anyway at some point. So to figure out the term in the middle when you square a binomial, you simply multiply the two terms and double it. So I'm going to get rid of all this except for the top line. Actually, I want to keep that part. And verbally call out the easiest way to square a binomial. Square a binomial. You square the first part, x squared. You square the last part. Now be careful. When you square it, it will always come out positive. Negative 6 squared is positive 36. But in the middle, all you have to do is multiply these two and double it. When I multiply them, I get negative 6x. When I double it, I get negative 12x. It's just a quicker way when your FOIL problem is really one binomial squared. If you get past that, you'll see, oh, surprise, surprise, it's a quadratic equation. So we're going to have to solve it the way that we always solve them, by getting things equal to 0. Let's empty out the left side by subtracting 2x from both sides and subtracting 3 from both sides. Keeping the moves balanced will keep the equation equal. Usually, there's 2 moves where that violates that. We've seen them already. But on the left side, everything cancels, leaving a 0. And on the right side, we have an x squared. Minus 12x and minus 2x is minus 14x, and positive 36 and negative 3 is positive 33. Okay, so now what? Well, we can either break out the quadratic formula or we can factor it. And I'll tell you right now, every problem in this homework assignment and the previous one about rational equations, if you run into a quadratic equation, it's going to factor. You can use the quadratic formula. But those problems are usually set up to factor to give you clean solutions, because you have to check them. And when you have to check a solution like 1 plus the square root of 5 over 2, oh my gosh, it's not impossible, just not very desirable. So these problems are designed to have clean answers, which means if you run into a quadratic equation, it can factor, or you can use quadratic formula. But I digress. This factors into x minus 11 and x minus 3. If you're not sure why, FOIL it out and see why those two numbers have to add to give negative 14 while simultaneously multiplying to give positive 33. All right, at this point, it's factored and equal to 0. That's perfect. You put x minus 11 equal to 0, You put x minus 3 equal to 0, and you get x equals 11, and you get x equals 3. Woohoo! We made it. We're at the end. We reached the goal. It says x equals. Ta-da! It's a homework question. You go in, you type in 11, 3, you check it, and it goes. Why does this man do this to us? Everything that's happened so far is correct. We just didn't finish all the steps. Ha-ha! Remember, the fourth step says check your solutions, and it's not just there for me to annoy you. It's there because it is a necessary part of solving square root equations, and more specifically, it is a necessary part of solving any equation where you square both sides. Squaring both sides is a move that can create extraneous solutions, and it's a necessary move here, so we must check for extraneous solutions. So we're going to go to this original equation, plug in our numbers, and see which ones work. All right, let's write the original equation since it's not on this page. It was the square root of 2x plus 3, and then outside plus 6 is equal to x. And we'll check each solution one at a time, starting with the 11. We check x equals 11. We can go to both sides of the equation and put an 11 where there's an x. On the left, we get under the square root 2 times 11 and then plus 3. And then plus 6 is still there, equals. But we're also putting in 11 for the x on the right side. So the right side becomes 11. And just like before, we work each side separately. And we see if we get the same answer on both. All right. So let's start with the, well, the right side's easy. The right side's just 11. There's nothing to do over here. So it's the left side we got to focus on. Under the square root, 2 times 11 is 22, but we still have the plus 3 under the square root and the plus 6 afterwards. Still under the square root, 22 plus 3 is 25. Square root over that, we haven't done it yet, and then plus 6. I think you can see this is going to work. The square root of 25 is 5. We still have the plus 6. 5 plus 6 is 11. Success. The 11 worked. Let me move this over because I do want to make room to check the other solution, which was x equals 3. So I need to grab everything except the top equation and just drag it on over a little bit. And then we'll put a little line dividing our two checked solutions. I guess we'll do one across the top too. There we go. Look at that. All right, now let's check the other one. Now let's check x equals 3, I believe was the other solution. And we'll start it below this line. The square root of 2 times 3 plus 3 under the square root plus 6 outside the square root is equal to, and remember we're checking x equals 3, so the right side of the equation will become 3. And now we just have to check to see if the left side will equal 3 because the right side is already equal to 3. Starting under the square root, 2 times 3 is 6, but we haven't done the plus 3 under the square root yet, or the plus 6 on the outside. Under the square root, 6 plus 3 is 9, but we haven't done the square root yet, nor have we done the plus 6 on the outside. The square root of 9 is 3, haven't done the plus 6 yet, and 3 plus 6 is 9. And more importantly, 3 plus 6 is not equal to 3. So no, bad solution. Angry face. I did all that work and I got to throw in an answer. You are now dubbed extraneous. Extraneous. Maybe bump that font size up just a little bit, and there we go. Okay, so that means that x equals 11 is the only solution. I'm about to type that. Come on, text, there we go. Only solution is x equals 11. Let's do this. There we go. Only solution is x equals 11. So it's an annoying part of these type 2 equations where, and remember what made it a type 2 equation was the variable on the outside of the square root. Because if there's a variable on the outside of the square root, then when we do the squaring move, that variable becomes squared. as it did upon this move, which created this x squared, which created a quadratic equation, which created two solutions. Usually, sometimes it's one. But more importantly, squaring can alter the truth value of a statement, and therefore extraneous solutions can step in. I don't think there's a need to do another example because it's just going to be more of the same. Just be careful that when you have a variable on the outside, when you have a type 2, a variable on the outside, you will run into a quadratic equation, and you will have to solve it by factoring of the quadratic formula. And you'll probably get an extraneous solution. I say probably because I've seen type 2 equations like this where one solution works, one doesn't. I've seen them where they both work, and I've seen them where neither work and the equation has no solution. So you can't take anything for granted. You do have to check them all. All right, we're going to take a look at one more video, and then we will call it a series. Hooray.